Trick to count number of triangles in a figure. This is a triangle. Now, this can be divided into different triangles in multiple ways. Consider one of those by joining vertex to the horizontal line. This way, we can divide the triangle into multiple triangles. Now, to count the total number of triangles in this figure, we can use a simple trick. The trick can be used to answer other questions as well. In all these different cases, the same trick can be applied. Now, let us start with this. For that, first check the horizontal line and see the triangles that have this as base. Here we have 4 such triangles which have the horizontal line as base. The total triangles in this figure can be obtained by adding these numbers. So 1 plus 2 plus 3 plus 4 is 10. Or in case when we have so many lines coming from the vertex to the horizontal line, instead of adding like this, we can simply multiply the highest number with its successor. Here the highest number is 4. 4 into successor means the next number. 4 into 5 and then divide this with 2. That gives the answer. Now let us check this answer by counting the individual triangles in this figure. This is the case. First thing with a single triangles, then two triangles taken together, it will look like this. If we take three triangles together, and then finally all the four triangles together. Now count these triangles, and that gives the answer of total triangles hidden in this particular figure. Now let us take this case. Here we have multiple horizontal lines. So we will calculate the number of triangles for each and every horizontal line separately. Consider the bigger one here. Now in for this line we have 6 triangles. To calculate the total number of triangles formed with this horizontal as base, we will just do 6 into 7 divided by 2, that gives 21. The next horizontal line, and with this we have 4 triangles. So total number of triangles that are formed using this particular horizontal line as base can be obtained by multiplying 4 with 5 and then dividing it with 2. That is 10 here. And the next horizontal line, here we have 3 triangles. So 3 into 4 divided by 2 gives 6. And the last horizontal line, 2. So 2 into 3 divided by 2, that gives 3. Now add all these numbers. This gives total number of triangles in this figure. Now consider this case. Here all the horizontal lines are touching the sides of the bigger triangle. In such a case, just count the number of triangles for one of the horizontal lines. Here again we have 6 triangles with this line as base. So 6 into 7 divided by 2, 21. Every horizontal line will have the same count. Add these, that is 21 into 4 gives 48. The next case, here the upper portion and the lower portion both are identical, so just count for one of those. Now I will be doing this for the upper portion. For the upper portion, with this horizontal line we have 6 triangles. So 6 into 7 divided by 2, again this is 21. As the lower part is a replicate of the upper one, even the lower part will have same number of triangles. So the middle vertical line, either side of this line are symmetrical. So with this line as base, we can form different triangles. 1, 2, 3, 4, 5, and 6. In short, to tell, whatever the number of triangles we have with, for the horizontal line, the same number of triangles can be formed for the vertical line as well. So simply add 21 for the upper portion, 21 for the lower portion, and 6 for the vertical line. This gives total number of triangles in this figure, that is 48. If at all the middle line isn't there, the vertical line is not there, in such a case, count the number of triangles for the upper portion as the Lower part is replicate of the upper one. Multiply that particular count with 2 and that gives the answer. In this case, we can see there are 5 triangles with a horizontal line as base. So the total count would be 5 into 6 divided by 2, that gives 15. Multiply this number with 2 and this gives the total number of triangles in the figure.